Hello, everyone, and welcome to another Into the Terminal. Today, we're going to be talking about hardware. Nate, go ahead and jump us into the terminal. We can go into the critical path.
Yeah, let's do that. All right. So hardware on Linux can sometimes be a little, I don't know what the word I'm looking for is, hard to deal with, mainly because you're at a terminal, right? And unless you've got a GUI environment like Scott probably does, hardware can sometimes be difficult to find, especially if you're coming from a background where you had a GUI. Like, certain other graphical operating systems have a really nice tree-based listing of hardware, so it's sometimes easier to find stuff. And if you don't know the right tools, well, maybe you can't find those things on Linux. So we're here to show you some of those tools. The first thing, which has existed like forever, is just plain old /dev. Everything that shows up on a Linux machine ends up in dev. Every piece of hardware, right? And some of these are like virtual devices. Some of them are like, if you set up like a multipath device, it'll show up as a virtual device here. If you have an LVM, they'll be under dev mapper. You'll have an LVM virtual device that maps to a physical disk or like the logical thing that is your virtual disk. And then, of course, there's things like actual drives, right? Like these VD devices, VDA 1 through 4. That's like, so VDA is my first virtual hard drive that's connected to this machine because this is a VM. VDA 1 is the first partition on that. VDA 2 is the second partition on that, right? So you can kind of see where that's going. If you've got a SCSI device or a SATA device, it'll show up as SD instead of VD. Old days of IDE drives, they showed up as HDA, HDB, right? So there's a lot of different nomenclatures there that you might want to be aware of. But that's where you're going to find things like hard drives. So if you attach the new hard drive, it'll show up here as a dev VD, dev SD, something. And I think there's another, there's two others for NVMe disks, show up as NVMe 0, NVMe 1, right? And don't SD cards show up as a different structure as well, I think. I could be wrong on that. It's like MMC BLK or something like that because it's more like a memory card.
I've not seen that one. I've seen some like weird hardware RAID controllers show up as different things.
Right, right. Software RAIDs will show up as MD, I think, because the MD Atom is what created them. So there's a lot of different ways that these might show up, but usually a device like that with then a letter and then a number, it's possible because that's like a common formatting for disk devices. All right, so enough about disks. There is one other storage device I wanted to talk about, and that's this dev CD-ROM. You see that there? We do an ls-l on dev CD-ROM, you're going to see that it's a link to SR0. And I don't know what SR actually stands for, but I know that that is commonly used for CD-ROM drives or SCSI CD-ROM drives. And you'll see later with some of the tools that we're looking at, the CD-ROM drive on this machine actually shows up as a SCSI device, right? So I guess that's why it's SR0. But that's where you're going to find, like, if you have a physical CD-ROM or DVD-ROM connected to your machine, it won't change based on DVD versus CD. It'll still say CD-ROM, which goes back to the old days when these were all CDEs. Optical discs were all CDs. So if you've got, either a virtual or physical CD-ROM connected, or an ISO, if I attached an ISO to this machine to do like an installation or something, they'll still show up as dev CD-ROM or dev SR0 or whatever you're mapped to. All right, let's see. The next thing I wanted to show you all was these TTY devices. Now, there is a bunch of uses for TTY, or a bunch of device types that show up as TTYs. Some of these are virtual consoles, right? So some of these map directly to virtual consoles within the system. If you were to send characters to that TTY, they'll show up on that particular console. Not like terribly useful, but also could be useful depending on how people use your system and things like that. If you can tell what TTY someone's on, you could like send them a message or send them an alert. You can automatically send alerts. Go ahead, Scott.
Nate, if you run the TTY command on your shell right there, you'll see what TTY device goes with it.
Look at that. I'm on dev PTS 0. Probably, I think that's because I'm a remote shell, not a local shell, right? Yeah. There's also special TTYs that are these TTY capital S and then a number. these are actually mapped to serial ports. So if you remember in the days when we had physical 9-pin serial ports on the back of our physical machines, that you could then communicate with certain types of hardware, like, I don't know, in the old days, you'd use like a modem this way. There's serial-to-serial communication between two machines if you wanted to talk over a serial connection. There's also things like console connections to network gear that you might be using a serial port for. But this, you'll use a terminal emulator to connect to that serial port. Or in a Linux world, you can literally just use like cat, right? Was it cat? Now,
No, there
there
was
are
a serial that I've forgotten.
there are some super basic serial. Oh, screen is what I'm thinking of. You can use screen to just like connect to a serial port, and then you've got a terminal on that port. That's what I was thinking of. You can use cat to send commands to it, but probably not a good thing because you might not see the result of the command. So TTYS and then a number will be a serial port or a serial device. If you have a USB device that emulates a serial port, that'll show up as TTY USB and then a number, right? So not every USB thing you plug in shows up that way. Scott and I were tinkering with this before the show so we could try to make sure we're giving you the right information. Things like block devices connected on USB don't show up as TTY USB. But a serial port, or like I was using the example, I have a little radio that's plugged into my home assistant machine. That shows up as a serial connection because that's how Linux talks to the radio that's on the thing. That shows up as a TTY USB and then a number, right? And I think that's probably, let's see, enough about dev. I got a couple other tools I wanted to show you because, again, talking about finding and looking for hardware on your machine, a lot of times when hardware changes or when hardware is failing, like has errors or whatever, you're going to see messages displayed. They would be displayed on the console of your machine if you had a console. In the case of a virtual machine, you might have a virtual console. But in the case of like a physical machine, you might have to connect a monitor to it. That's not exactly convenient, but there are ways to see what's on the console or see what's been logged on this system, even if you're remote. And one of those is DMESG, DMESG. And there may be nuance here, but as far as I've seen in my experience, generally what's displayed on the console, like errors that show up on the console, will also end up in DMESG. But DMESG, here we go. We can see that this is kind of like things that happen early in the boot sequence will end up in DMESG, and things that happen to change the hardware will end up in DMESG. This is like a lower level system log than var log messages or the journal, the system journal are, right? So another place that you can look if you're connecting new devices and you don't know where they went or whatever is DMESG. All right, and along those lines, we still have the good old var log messages, which you might say, but that's been replaced by the system journal. In some cases, yes. In some cases, no. var log messages still exists, and it shows some of that data. You can see there, well, we're going to go through a demo of this later, but you can see there I attached a SCSI, or I attached a USB stick to this in testing, and it shows up in var log messages. It was also in DMESG, right? So it's in both places. Some things are there, some things are in DMESG, some things are in the system journal, which is the last thing I wanted to show you.
So actually, Nate, anything that goes to DMESG also goes to varlog messages because the syslog rules make it so.
There are things I have found early in the boot process that do not end up in messages.
Oh, because you're not yet running our syslog,
right?
And so hasn't received them.
Right. So not everything. Most things. How's that? Most things. So there you go. All right. But DMESG is a handy tool, and it's easier to type, right? Versus cat varlog messages, right? So I'm going to stick with my DMESG, Scott, and it's color coded.
So I will. DMESG is the kernel message ring, and there's a finite size of memory that's used to store it.
Yes.
So just like you said that you lost early messages for syslog, if enough activities happen on this machine, you'll start to lose those early messages out of DMESG as well.
Yes. Yes, that is also true. So yes, varlog messages for persistent stuff. All right, so that last thing was journal control. right? There are command line switches to journal control, which make this easier to read. But for the purposes of just the quick critical path here, I'm just going to show you journal control. You can see there's a bunch of data in journal control. It's paginated. It's got a pager, right, that lets you scroll up and down. And don't forget to scroll left and right if you see a very long message. There are flags that'll make that wrap, but I didn't use any of them today. But if you can't find it in var log messages and you can't find it in DMESG, it could be in the system journal. Commonly, the system journal is things that come out of systemd, right? So services starting and stopping, the actual process of starting up systemd, that'll all end up in the system journal. There are system logs that also end up in the system journal sometimes, but that comes down to like how things are filtered and redirected as things are running and whatnot. And yeah, there you have it. That's my critical path for today. You got any comments on that, Scott? Anything I missed?
I've already made them.
You've already made them. All right, cool.
So stick with us. We're going to get into a whole bunch more command line utilities to inspect different types of hardware after we come back for the deeper dive. Don't forget to mash that like and subscribe button, and we will see you in just a second. All right. So now is the time, of course, where we take questions from our audience, or if you're a deferred viewer, please feel free to leave a comment. Both Nate and I are pretty good about responding to those if we see them. So Nate, we're going to be talking about a whole bunch more commands.
Yeah,
And
like I said in critical path, like this is one of those things that once you know how to find hardware, it's like you've uncovered a mask, right? Like the veil is lifted. Now all of a sudden, it's so much easier to deal with things in Linux because you know where to find the data that you need.
we did get a question from Shantanu.
Okay.
Wouldn't journal control be the way to get early DMESG messages since boot since boot is a parameter of journal control?
I would have to actually go look and see what the differences are between DMESGs and journal CTL. I would think boot messages that happen before systemd has started might get missed and would be in DMESG but not in the system journal. Do you know different, Scott?
So I know that as part of the boot process, at least for our syslog, it actually grabs a copy of the DMESG and sends it to our syslog. I wouldn't be surprised if the same thing happens with journal D.
But DMESG is still easier to type than journal CTL. So I'm sticking with it. No, DMESG is an older tool is really what it comes down to. And like a lot of things, as the operating system progresses and as things get improved, the old tools stay because people are so used to them, like people like me that are used to the old tools. But there could be 2 or 3 ways to get the same data out of a machine.
Oh, and Nate, I just noticed we're wearing the same shirt today.
Yeah, I just noticed that as well. So if one of us just goes like this, it doesn't look so bad. It was
All
the
right.
next one in the stack when I was looking for a shirt today. So
For sure. All right. So do we want to get into some of our bus or device specific commands?
yeah, so let me get my share back up here. All right, so there's a couple other really handy tools, and we've talked about some of these in the past on this show and on some other shows. I remember Eric and I did like your top 5 favorite Linux commands, and I covered some of these because I think they are that helpful. That was like maybe a year ago at this point. But LSUSB, right? So say you've connected a new USB device and you're not sure where it is, or say you just want to see what USB devices are connected to a machine. Now, obviously, a USB device being connected is generally a physical act, like you have to be present with the server. But there are cases where maybe you're remote. Maybe you had someone in your data center plug in a USB stick for you, and you're like, okay, now where is it? Did they plug it in? Is it there yet? That kind of thing. So we already showed you DMESG and how when you connect a disk, a new SCSI or a new USB device, it'll show up in various system logs. One of those is DMESG. I like DMESG. We've covered that already. But you can see right here, while we were talking, I mapped a new USB bus device to my VM. And you can see right here, it says that there's a new device. SDA is where it got mapped to. It tells me things like that it's a SCSI disk. It tells me things like how big the disk is. Handy stuff. If you mapped a new drive that's a SCSI device, or if you mapped a new drive that's a virtual disk device, it'll also show up in this log, right? So again, DMESG, var log messages, and probably the system journal, since we've covered all three of those at this point. But that isn't all. What I really wanted to show you was a cool utility called LSUSB. What this does is it asks the system to show me everything that's connected to the USB bus, right? So I don't care if it's a disk device or a virtual serial port or I don't know, whatever, that radio that I talked about. If we do LSUSB, it'll say, hey, here's everything that's on the USB bus, including the root hub, right? So it'll tell you how many root hubs I've got, what version they are, right? See, this is a USB 3 root hub. This is a USB 2 root hub. And then right here is my QEMU USB hard drive. That's the thing that I connected, right? And if we were to look at dev SDA star, we're going to see, look, there's dev SDA. So now I could go say, make a partition on dev SDA, map that to a place on my system. If there's already a partition on there, I don't know what tool supports this, but if there's already a partition on there, it'll automatically mount it inside of, where is it? Is it var run media still? We've moved this a few times.
That's a function of the graphical desktop environment.
There we go.
So and I can't remember which utility it is in GNOME that will perform that automatic mount. But
right,
it doesn't
but
happen
it's super
running in.
okay, right. It doesn't happen when you're on a server like this. So you'll have to find the thing and map it. But if you are on a desktop environment, it'll find it for you and mount it, which is actually super handy because that's what you expect on a desktop environment. All right, so there's a couple other tools that we can talk about here in the same vein. Just like LSUSB, there's an LSPCI, right? So say you're trying to figure out where your video card is. You know, you're in like one of those quagmires where you're like, why doesn't my NVIDIA card work on my laptop? I need to know what kind of card it is so I know what driver to go download. LSPCI will show you everything that's connected to the PCI bus. And things like a video adapter will show up in this list, right? So you can see here, I've got PCI root ports and here, Intel Corporation interface controller. What is this? Oh, here's I think this is the video card, the virtual video card that's attached via KVM, right? I think that's SM bus controller, right? I'm going like deeper here than I need to. The point is, anything that's on the PCI bus should show up in LSPCI. Again, handy if you're trying to figure out like, where's that video adapter I'm trying to set up? There's another tool that's good for listing SCSI devices, LSSCSI. Are you detecting a trend here? Listing SCSI devices. You can see here, there's that CD-ROM that we looked at inside of dev earlier. And of course, because that USB device is technically a SCSI device, or it maps it as a SCSI device, it is there in dev SDA, right? So there's my USB disk. Again, any SCSI devices that you have connected to the machine should show up in here. Any local SCSI devices. Go ahead.
Yeah, and this is really handy if you're dealing with maybe in your company you have another team that does storage mapping, and you've added APU storage and you're trying to figure out where it is or what it is. If you grab an LSSCSI beforehand and then they're like, it's done, you can LSSCSI afterwards and see if it shows is connected to your machine. And then you'll also be told what device ID it was assigned when it's connected to your machine.
Right. Right. Handy. Will this cover things like iSCSI devices and fiber channel connected disks?
So fiber channel, yes. I've never tried it with iSCSI connected devices.
I could totally go off the rails because my home lab uses an iSCSI device, but let's not do that. All right. So yeah, LSSCSI. There's another great tool for listing all the block devices connected to your system, and that's LSBLK. I like this one because it gives you a nice tree of like where the block devices are, what partitions they have, and in this case, it even shows me that I've got LVM volumes within VDA4, right? Even shows you where they're mounted. Really handy stuff. So again, using my that CD-ROM drive here as an example, there it is. My USB disk that I connected, there that is, right? So LSBLK for listing block devices.
And Nate, throwing it back for a second, I had never seen this before, but Andre said LSPCI-K shows the kernel driver loaded for the different devices.
That's handy. Usually I would have just gone to LSMod to try to see what was there, but this is actually really nice. Thank you for that. See, you learn something new every day on Into the Terminal, Scott. Even we do.
That's right.
All right, and let's see. Actually, that's the end of my list, Scott. Any other questions or comments before we move on?
No, I don't think so. I think we're going to move to some more commands that look at kind of general hardware attached to the machine. So this is my box, and here we go. We can do something like LSHW, that's list hardware. I'm going to pipe that to less because it's a big list. And what it does is it probes your machine and looks for all the different components of hardware that it can detect and recognizes by the kernel. Now, this is a virtual machine instance running in Google Compute platform. So you can see that like the description of the computer is a GCE system, and the motherboard is a GCE system. And you'll find out that a lot of virtualization solutions do this. I bet if Nate did this on his machine, he'd see QEMU stuff because that's the virtualization solution that is used by default by KVM. But like VMware will do this, VirtualBox will do this. And so it's really handy if you are in a virtualized instance. If you actually want to see kind of what's providing your virtual infrastructure, looking at some of the vendor settings in something like this or another utility I'll show you in just a second. So it also,
and this was one that I learned about planning this show because I hadn't used LSHW before. This is nice that it kind of groups everything all here for you.
Yeah, and there's another one that I use that's older that personally I prefer, but this is kind of a redux of that utility. So like it goes through and shows you your CPUs that are attached and all the CPU flags that are on it, and the different memory things that you've got. So if you are on a server system where there's like actual memory modules, it'll go through and tell you like the size of each memory module. And if you are using banked memory, it'll go through and describe like what the banks are configured as. I don't know if people have seen this before, but you may open up a server chassis and not all the memory modules are populated, but there's like two or four different groups of them. If that's the layout in there, oftentimes they're banked, which means that you want to add pairs to each collection of memory modules. And it does things like buffering between them and caching a little bit, and you get some benefits from the hardware that way. PCI bus, and then it goes through and actually like shows you the different devices attached to the PCI bus. We were actually looking at that earlier with LSPCI, right? So there's my virtual graphics card, looks at my different disks that are out there and their formats, network controllers. So it's going through and kind of classifying some of the devices it has and telling me things like the description and its device name if it exists on the system and so forth. So that's LSHW. I mentioned that I use an older tool that I've developed a preference for, but that's because it's an older tool that I've used for a really long time called DMID code. Right, and DMID code gets data from the BIOS, or actually the kernel reads from the BIOS when it is in first unpacked and executed. And so what we're looking at with DMID code is that BIOS information or BIOS information. LSHW then takes the same information, just kind of like reformats it. So you'll see a lot of the same stuff here. And so things like the BIOS manufacturer. So again, you'll be able to see Dell, HP, Lenovo, GCP, Amazon, VMware. A lot of times for the hardware manufacturers itself, either in the BIOS information or this next section in the system information, you'll get the serial number or service tag ID. So you are working in a data center, you don't want to have to like go to the physical computer to read the sticker that's on it when you want to open a support case with your hardware vendor. A lot of times you can get the information you need out of this tool, out of DMID code. Um, uh, Chassis information, processors, right? So here it goes in a little bit more detail and tell me things like the caches that are included in the processor, as well as its speed. It goes into the similar description of memory, just like we saw with LSHW. And then each individual device. So this is a single DIMM that's 4 gig that's exposed to it. And yeah, that's pretty much it.
It's a bunch
So
of
that's
info. There was a quick comment on the word BIOS that you used. Was it Billy, I think, or someone said BIOS? People still use BIOS. Obviously, we've moved away from like the old BIOS style hardware machines to UEFI or EFI. However, this still reads those as well, right? It's not like this is a tool that only reads older school BIOS systems, right?
right. I think the reason that we're seeing it's well, BIOS is kind of a catch-all term that talks about like
Yeah,
hardware manufacturer information. So even though the machine may be a UEFI bootable thing, it doesn't actually use BIOS boot. Um,
right,
the same metadata is put in there by the manufacturer.
right. Just for clarity, that's the only reason I brought it up.
DMID code also has a couple of options, so you can look at specific subsystems. So you could do a DMID code -T processor, and it just shows you the CPU stuff out of DMID code. Or we could do a DMID code -T system, and it just gives me that like system information, like its serial number or service tag or whatever. And if you wanted to see more categories, if you use it incorrectly, it says, here are the options you can provide to -T to see the specific things attached. All right. Now we're going to take a slight turn and talk more about like kernel-y things. So I was going to do this a little later, but I think this probably fits in well now. There is another ls command that I like, lsirq. So just like we saw earlier, you could use lspci. Thanks, uh, Andre, for -K. You could see the kernel driver, the kernel module that goes with it. Well, this also tells you, like, for the interrupts that are on the machine, which ones are assigned and to what device are they assigned. And so we can see things like which interrupt our network interface card is on, or our VGA card, or the USB bus. And so the first column there, the location column, that's the actual IRQ number that is assigned. The total, that's the number of IRQs that have been sent to that number or to that device, right? IRQ is an
Yeah,
interrupt request.
that's cool.
So when the kernel is like doing stuff like networking, for example, a packet comes into the network interface, and the network interface raises an IRQ to the kernel, say, hey, I got some data, you got to pay attention to this thing. And then the kernel will go and like read the data off of the network interface controller.
And I
So
remember setting IRQs with jumper pins. That's how old far back my computing history goes. Now they're all
and,
soft set on hardware, I'm sure.
yes, they are. And the reason I bring it up is that um, you can actually assign IRQs to be serviced by a specific CPU. So that the load of like IRQs is borne by a specific CPU core. But it also can give you a sense of scope. So like this machine is not very busy because it gets local timer interrupts. That's like every often the kernel needs to check to see if it needs to change the running process from the CPU to something else in the run queue. That's the local timer interrupt. So that's how long my machine has been running essentially in interrupts. But then we can look at like the VirtIO 0 and VirtIO 1. Those are the next two biggest use devices where data is flowing in and out. I would guess that these are actually these are disks, if I had to guess. I'm sorry, no, PCI. They're network cards. And then the next one down is Dev TTY S0. So there's a serial console, but you will see these numbers get like increasingly large, which might indicate problems. So if you're troubleshooting and you think that you're like being killed by network traffic or something, you might be able to see it here in LSRQ. All right. A lot of the tools that we just showed you are gathering data from the kernel. Well, there's also a place where the kernel stores all of its information, right? So if we go out to /proc, there's a whole bunch of files here with stuff about your machine. So for example, when I did LSHW and whoops, and we looked at the CPU stuff, right? So here's the description of my CPU and the processor flags and things like that. Well, that was really coming from proc CPU info, right? So there's information about my machine, including processor flags and stuff. But this gives you even more. So for example, if you look, let me go up one or two things. You can see the physical ID. So if you have more than one socket, the physical ID tells you which socket this CPU is on. And then there's the core ID, right? Because we have multi-core systems, so each socket can have multiple CPU cores on it. So it'll also tell you the core ID to go with the CPU in that socket. And this is important for things like pinning, process pinning, where you can say these things belong to this CPU, should only be serviced by the CPU, or you want to make sure that things like if you have jobs that are related to one another and you are pinning them to a CPU, that you pin them to ones on the same either core or the same socket, because the same socket is going to share caches between the cores. And so if they're two related things or two identical processes, just like web server daemons, for example, they can get some help from one another by sharing the same cache with one another. So even though they might be running on different cores, if they're running on the same socket, they can get some benefit from sharing the same CPU cache on that socket. Nate, have you ever paid attention to these flags?
I was actually just going to call attention to the flags section because there can be some really useful info in here if you know what you're looking for. Stuff like, does this CPU support virtualization? Right, is one of those flags. These flags are basically all features of your CPU, and a lot of these map up to the specs you'll find in CPUs throughout the year. Like you see MMX up there. I don't know if you remember when MMX was a big deal like 20 years ago because of multimedia processing. I
Yeah,
think HVM is what I'm thinking of. Hardware virtualization. I think HVM is the thing that I see hypervisor in the list there too.
So it will vary based on the CPU manufacturer.
True.
So I think AMD uses HVM and or actually it's the SVM. Thanks, Andre, in the
VMX and SVM. Yeah, there we go.
yeah. VMX is the Intel flag for hardware-based virtualization. Now, neither of those exist on this CPU because
It's
this
virtual.
CPU, yeah, that's right. And that's actually why this one shows this flag.
There you go.
This is a VM running on a hypervisor. But so these different flags indicate the capabilities of your processor. So things like trusted compute flags that are available, right? Can your processor do trusted compute stuff? We talked about the virtualization ones. Can your CPU do virtualization? And then there's a
Right.
bunch of old ones. The MMX one that Nate referenced, that
Yep.
actually came into Intel set in 1997.
Yeah.
Because I
SSE and SSE2. I remember those two. Those were, I can't remember what they were for, but I remember them when they showed up. That was a big deal about SSE. I forget what it was now.
Yeah, and then there's some that like we don't really even use anymore, like PAE, which is physical
Yeah.
address extensions for 32-bit systems to be able to like address more than 32-bit memory addresses. So, um,
Are these
we
like
tend
in
to.
order when they were added too? Because it seems like the older ones are all up there at the top.
I don't know, but so I was doing a little
Sure
bit of
feels that
research because last night I actually wanted to make sure that I had my virtualization ones straightened out, and so I found this really
way. Yeah.
nice wiki page that had broken down by vendor like the common ones, and then ones that you sometimes see. Um, and it also had like release dates, which is how I know the MMX was 1997,
Yeah.
along with the Intel advertising that we got in the Super Bowl with the guys in the silver suits dancing from the fab.
Yeah. The bunny suits.
That's right. Uh, anyway, so we digress. Um, a lot of this information is also in proc. Now, this machine has one CPU. So that's why we saw one CPU listed in proc CPU info and why we only saw
Right.
one CPU listed in DMID code and LSHW. If you have 8 or 12 CPUs, there will be 8 or 12 entries in this file or in those tools. All right. The other one I wanted to show was proc partitions. So earlier we looked at a couple of utilities to look at like what disk devices are on my machine. And we looked at like LSCSI, which showed you SCSI devices. But disk devices may not just be SCSI, right? We talked about how like RAID controllers might be, was it CCISS or something? There are some weird ones that you'll see. Well, proc partitions will be where the kernel stores all of its recognized disk devices plus the partitions that are resident on them. That's also a place where I don't know if you ever experienced this, Nate, where you create a partition on disk and you write it out with your disk partitioning utility, but when you try to work with it, you get errors about not being able to find that partition that you just added.
Hmm.
And that's likely because this file has not been updated because the kernel uses it for actually interacting with these devices. So that's where things like part probe actually tells the kernel to refresh its
Yep.
list of recognized disk devices and partitions. And you can see it like if you run part probe and there's a new device, it'll actually like be immediately listed in this file if it wasn't there before.
Yep. Now, what this doesn't give you is where they're mapped or whether there's an LVM in there, but it gives you like the raw disk data, which is helpful.
Right. And things like size, right? That's what the number of blocks
Yeah.
tells you.
Yeah. Right. Right.
All right. So, Nate, I think those were the list of things that I wanted to cover. Um,
Yeah, the last tool I wanted to bring attention to, and I don't have a demo for this because it requires a physical disk that supports the Smart protocol, which is basically like a disk health monitoring protocol. So if you're on a virtual machine like my lab is, Smart Control gives you nothing. But Smart Control, if you have physical disks, can be a useful tool for checking the health of your disks, which is really its core purpose. There may be other uses for it, but if you have physical disks there is smart control. It's like smart control dash utils or something. I think is the package you'd want to have installed. It's probably there by default if it's a physical machine, and you can use that to monitor the health of your disks. So just keep that in mind if you're on a physical machine.
yeah. And I will say that if you start noticing smart control messages being thrown into your varlog messages, pay attention because they're
Yeah,
probably telling you your disk is dying a slow and terrible death.
Yeah, smart is something that's literally on the disk controller. That circuit board that is on your physical hard drive contains like whatever extensions or whatever smart control is talking to. So if it tells you there's a problem with your disk, this isn't a software glitch. It's the disk itself saying, "Hey, look at me."
And the ones that are really bad are the seek error messages or the write error messages. A seek error message from Smart Control is telling you that a request came in to retrieve a block off of that disk and it couldn't find it. That's bad that you're losing data off of your
Yes,
machine. The other one is the write errors. So it received a write request and it tried to write data to a specific part of the disk and that failed because for whatever reason, the disk platter was damaged or whatever. It wasn't able to actually persist that piece of data. So now you're
yeah,
not writing data you need to write. And disk controllers are good. Like they'll try to rewrite that somewhere else as well. But the fact that you're either having data vanish from your seek errors or having
right,
data not being written is indicative of that disk failing. So
right,
you'll want to make sure that you have an active backup, and you probably want to start scheduling a maintenance window to replace that disk with something else.
right, right. I have lots of horror stories from my sysadmin days that started with seek and write errors.
Ignore them at your peril.
Yes,
But
do not ignore those. Bad idea. Bad things happen if you ignore those.
all right, so I think that brings us to the end of our planned things today. So this has been finding out information about your hardware. Nate,
Yeah.
any
Just that being able to find hardware connected to your Linux machines is super important. If you're fumbling your way through this stuff, hopefully one of the tools in this episode helps you stop having to fumble. And yeah, if you've got any tools that you like that we didn't cover, put them in the comments or put them in the chat. Although we're almost done, but yeah, let us know, and then maybe we'll do another episode on more hardware tools for Linux.
Yeah, I see Billy just pointed out that CentOS Stream 10 is actually using x86-64 instruction set version 3 and later CPUs, or CPUs that have instruction set version 3. Version 2 instruction set CPUs are likely not to be supported or are not currently supported on CentOS 10 Stream and are likely not going to be supported on derivatives that come from CentOS 10 Stream.
But Scott, what would possibly be derived from CentOS Stream 10?
I don't know, maybe the Rel 10? Just spitballing.
Just an idea. If you want to try to predict the future, go look at CentOS Stream 10.
All
And
right.
J-Scar just joined. Hi, J-Scar. Sorry you found the end of the episode.
Bye, Jason.
Bye, J-Scar. All right,
Thanks,
folks. Have
everybody.
a great one.
Well, we had a programming announcement for the next couple of weeks.
Oh, right. Am I covering
So
that or are you covering that?
it's my fault, so I can cover it. So be traveling a lot the next couple of weeks. So we haven't decided yet whether Nate's going to be running the show solo, or we're just going to take a couple weeks off based off of my lack of availability. But we should probably get some episodes, but we'll see what they are based off of Nate's willingness to be the sole survivor of the show.
We'll figure it out.
Yeah. All right, everyone. Thanks for tuning in, and we'll see you on the next Into the Terminal.
Yeah, have a great one.